So last example from this section, I have a piecewise defined function, and I have two questions. Number one, is f of x continuous at x equals 3? Number two, is f of x differentiable there? So let's find out. When I say explain, you're gonna have to justify for me referring back to those important definitions. This is maybe the struggle that I see every year when I teach this. So at the beginning, maybe you don't believe how frequently, how often you're going to have to refer back to these important definitions. That's why I like to collect them all together on that important facts paper. And then it's not enough just to say f is continuous. You have to tell me why you know f is continuous. So let's practice. So f of x is going to be continuous at x equals 3 if the limit as x approaches 3 from the left of f of x equals the limit as x approaches 3 from the right of f of x, and that has to all equal f of 3. So that's not what it looks like on your notes paper. On your notes paper, it just looks like the limit as x approaches 3 of f of x equals f of 3. But for those two things to be equal, that limit has to exist, and the limit will only exist if the limit from the left is equal to the limit from the right. So I'm going to figure this out. The limit as x approaches 3 from the left. So with x values to the left of 3, x squared is the rule. So this is going to be the limit as x goes to 3 from the left of x squared needs to equal the limit as x goes to 3 from the right of 6x minus 9 is the rule that's active when x's are to the right of positive 3. And that's going to have to equal f of 3. I'm going to find by using the bottom rule because it's the bottom rule that specifies that it's active when x is exactly equal to 3. So it's going to be 6 times 3 minus 9. So as x goes to 3, what happens to x squared? That's going to go to 3 squared. This is going to go to 6 times 3 minus 9, which is what we already had here, which is 18 minus 9, which is 9. So does 9 equal 9 equal 9? Yes. I'm going to say f is continuous at x equals 3 because the limit as x goes to 3 of f of x equals f of 3. And notice I found all of those quantities. I found the limit as x goes to 3 from the left to be 9. I found the limit as x goes to 3 from the right to be 9. And I found f of 3 to be 9. So you can't write this part if you haven't actually gone through the algebra and found both the limit as x approaches 3 from the left and right, and also the actual value of f of 3. So now it's time to decide if f is differentiable at x equals 3. Well, for f to be differentiable at x equals 3, I need to know that the limit as x goes to 3 from the left of f of x minus f of 3 over x minus 3 is equal to the limit as x approaches 3 from the right of f of x minus f of 3 over x minus 3. These have to be, they both have to exist, and they have to be equal to each other. This is going to be the limit as x goes to 3 from the right. No, this is from the left. Limit as x goes to 3 from the left. Well, as you go to 3 from the left, f of x is x squared. So it's going to be x squared minus f of 3. We said in the last section, we already checked it out, is in fact 9. That's going to have to equal the limit as x goes to 3 from the right. Well, from the right, f of x is 6x minus 9 minus f of 3 is 9 over x minus 3. So I need to know, I could put a question mark here just to indicate for myself. I don't actually know these two things are equal. I'm trying to show that they're equal. I'm trying to find out if they are or are not equal. Well, the limit as x goes to 3 from the left. I can't replace x with 3 because I'm going to have a 0 over 0 problem. But I can factor this, x plus 3, x minus 3 over x minus 3. Those are going to cancel. I'm going to need that to be equal to the limit as x goes to 3 from the right. Well, 6x minus 9 is 6x minus 18. I can factor a 6 out, x minus 3. That's going to cancel with the x minus 3 in the denominator. So I need the limit as x goes to 3 of x plus 3 to equal the limit as x goes to 3 of 6. Well, the limit of a constant is just a constant. And if I replace this x with 3, now I'm going to get 3 plus 3 to make 6. So the limit, the derivative from the left was equal to the derivative from the right. So I would go back and write that up in one final sentence to say, yes, f is differentiable at x equals 3 because the limit as x went to 3 from the left of f of x minus f of 3 over x minus 3 is in fact equal to the limit as x goes to 3 from the right of f of x minus f of 3 over x minus 3. How about I just clean that one little part up a little bit? F of 3 over x minus 3. So I used all that algebra. Both of those were places where I could factor and cancel out. So then I could finally do my substitution. And I did. I got 6 equals 6. So these two limits are the same, which means f, by the definition of where f is differentiable at x equals 3. Final answer.